So we hear lots of people talk about thermal conductivity, and yes, it's important, but we'd never hear about water diffusion resistance and what effects that has on the efficiency and also the deterioration of insulation. So here we have some data sheets here showing you the thermal conductivities at 40 degrees. You've got 0.038, 0.040, you've got 0.042. So they're the thermal conductivities. On ours, it's 0.035. But what about water diffusion resistance? What does that have an effect on, and how important is it? Yes, we can see that deterioration and things happen, but what does that do to the insulation? Well, while I was doing all the research for Primary Pro, I was given this really good bit of information in a document. And this tells you water diffusion resistance, the absorption and the resistance to letting moisture go into insulation is really important. And it tells you there that it's talking about it being anything over 10,000 is good. When we've tested, 16,000 is okay. We want it higher. It also shows you here, every 1% of moisture lose in efficiency, thermal efficiency, by 7.5%. So really, every 1% increases the thermal conductivity by 7.5%. Let's have a look at the data sheets from the ones with the thermal conductivity. There we are. We have the water diffusion resistances, and they're all very low. One's 7,000, 3,000, 4,000. So they're very low. So they will absorb moisture. That is why we really worked hard before launching to make sure we got the best water resistance, and that's why we've got 39,000 on our mu value. So what will that do to the insulation, and how will it affect it? And as we can see, if they're not sealed up correctly, and if they're not insulated and all the gaps sealed, moisture will get into there, and then it has a real big effect. But what effect does it have on it? We see it all the time where there's gaps, there's holes, but what does that have long term? And will the insulation start to absorb more water? 1% is 7.5, but what about 30%? What about 100%, as you can see on these? And then we look at, a lot of people use plastic trunking. Now, plastic trunking is just a shroud, a cosmetic shroud. It still lets all the water in. So the insulation inside there has to have all these properties as it would do if it was outside. So it has to be sealed up correctly, clipped correctly. The water diffusion has to be high so it doesn't absorb the water, because it will have its own climate system inside that plastic trunking. And it can never get dry because it's inside the plastic trunking. And if you don't check it, you don't take the covers off, that will be a serious effect on the insulation. But how? Well, there we go. There's an example. So the thermal conductivity level is 0.038. 30% moisture would then add 225% increase to the thermal conductivity. So really, when it's wet, that makes it into 0.1235. From the videos we've seen, it's a lot more than 30%. So that is why damp insulation does not insulate, and why it's really important that we not only use the right products, but we also maintain, we fit them correctly, we seal them correctly, and we try and do everything. And this is what we've always looked at, and why we've tried to make the best insulation and tools. It also states in the standards, we've got to look at these standards and take a holistic approach and look at what they're saying, and then choose the product and the tools to do the right job. So there it tells you, will they be permanently deteriorated, or will they have a permanent effect, physical effect on the insulation due to moisture or temperature? And as we can see, if they're not sealed and they're not fitted correctly, and the wrong insulation has been used, which you can find on the data sheets, then this will have not only an effect on the heat pump, but it will have an effect on the system, and it will start to deteriorate rapidly. And that's why we've got to make sure that we're using the right products and also fitting them correctly, not just using the right product and it not be fitted correctly. And as we can see here, it starts the wrong products will start to deteriorate and also absorb moisture right from the beginning. Will then affect the insulation. We reduce the thickness of the insulation, and as we can see here, reduce it inside, so the moisture's got inside and it starts to deteriorate the insulation inside, and then starts to seriously affect the efficiency of the heat pump and system. So what we looked at is we looked at 5 main things after looking at all the problems and then trying to find solutions. So we want a good thermal conductivity, want insulation that protects from UV damage, want insulation that protects from moisture ingress, and a product to seal all the holes and joints, not just sealing the joints together, but to the heat pump, all the holes that you put through for the lever valves, all they need to be sealed to stop moisture and water getting in. And these need to be easily maintained, because we don't want to be stripping them off and chucking them into landfill, because things like this will take hundreds of years to deteriorate, and we don't want to use that. We want to use a product that can weather the tests of time and be easily to maintain. And that's what we've tried to do with all our products. Seal them up on all the joints, show you how to seal, look at all the areas, and try and help you with all the products and tools that we've got to try and make it look as aesthetically pleasing as we can on the outside of a customer's home or property, but also providing the maximum efficiency and longevity and maintenance. So when we're fitting all the pipework, we're making it easy then to insulate every valve and all around and clip correctly. This is really important to seal and cap everywhere. That is on the insulation around all the holes where the antifreeze valves and lever valves are, and to the heat pump. And as you can see, these are just some photos that have been sent by installers and how well it looks on a customer's house or property. Also, we've made the sealing rings and the sleeves, because it has to be sleeved through the fabric of the wall to protect the insulated pipework, and we know how hard it is to seal on the outside of the wall, so we've made the sealing rings as well with the grind head. If you're using a bending machine, our insulation is easy to slide on and bend round the bends, and then this helps you then so you don't have to make any joints. You can see this one going around the soil pipe again, just to provide the perfect installation for a customer's home and property.